Since the beginning of the pandemic, we have been very careful about not touching any surface because of fear that they were contaminated and consequently they could infect us. But what is true in all that? Can we really get infected by touching a surface? What is the science behind all this? Hi, I'm Marc and I'm going to talk about the interaction between the coronavirus and the human skin. Although the indirect transmission of COVID-19 through surfaces might be minor compared to air transmission, we should not ignore it, and it is also an interesting subject to study. The truth is that this type of indirect transmission is a rather complicated problem to study, since there are many factors to take into account, such as the way the virus is transferred from the surface to the inside of our body, and also the amount of virus needed to infect us. Among all these factors, in our research group, we tried to study, using simulations, the nature of the interactions between viruses and materials. Little is known in this regard, but we think that from the most basic aspects we can find important answers that could complement the experimental work being done. Specifically, what we have done is to research how the outermost part of the coronavirus interacts with the outermost part of our skin. In this way, we might reveal some important answers about the transmission of the coronavirus. But how do we do it? We don't do science in a laboratory or a hospital or anything like that. We simply use a computer where we use models of different materials, proteins, and other molecules, which are represented atom by atom. With these super detailed models, we carry out simulations applying the laws of physics to know how things change over time. To simulate the interaction between coronavirus and our skin, we need, first of all, a model of human skin. But human skin is a very complex organ with lots of parts, so for our simulations, we just use the outermost layer, the one the virus would get attached to. This layer by itself is very complex, so we just use the three main molecules that compound it: ceramides, cholesterol, and fatty acids. Now we have an approximation of human skin, but we also need to consider how the virus attaches to the skin, the spike proteins that surround the virus and give it its name. This can be easily simulated using data from cryo-electron microscopy that gives us the exact atom-by-atom coordinates of the protein. We complete the system by adding a droplet of water, which is how the virus is transmitted. And then we can run the simulation. And here comes the cool part. We do what we call a molecular dynamic simulations, which consists in applying the Newton's equations of motions to all the atoms of the system, but millions of times. In the equation, the force equals to its mass multiplied by the acceleration, and this operation is calculated for all the interacting particles in the system. We let all the calculations be done on a supercomputer, and then we can observe the interaction of the protein on the surface of the skin at the nanoscopic scale. Isn't it incredible? But this is not the only simulation we have run. We also consider a layer of sebum, which is a type of oil that covers our skin. It's made up of triglycerides, wax esters, and squalene. Looking at the results, we can see that the protein has tilted when landing directly on top of the skin, but it doesn't tilt when landing on the sebum. So we can expect that a virus particle deposited onto an oily skin will be able to retain the integrity and maintain its hydration more than on skin that has been recently scrubbed. The reason for this difference in behavior is the fact that the lipids that make up the top of the skin, such as ceramides, make many hydrogen bonds with the protein compared to the sebum lipids. However, it is important to keep in mind the limitations of our simulations. For instance, we are not considering the entire virus, but only a part of it, just the spike protein. So simulating models of the whole virus could give us more information. Studying the interactions that occur between viruses and their environment will help to better understand their nature and thus be able to intelligently apply measures against the transmission of different viruses. Because this does not end with COVID. Sooner or later, more viruses will appear and the world might be stopped again. And for this reason, it is important to keep studying the basic interactions that occur between the viruses and the environment. Thanks for watching. All the references for making this video are in the description below. I hope you like it. See you next time.